Alright, so this is on page 171, okay, section 14, okay, so applications of conversions and the rates, okay. As we just talked about, section 14 can be split into two parts, okay. The first part is about extension of the conversions from section 13, okay, but we're doing more dimensional conversions. Say we're going to talk about 2 and 3 dimensions conversions, okay. So I will just assign the pages that we're going to cover, okay, for this conversion part, okay. The second part of section 14, CO2 emissions, we'll talk about is the other day, okay, on the other day, okay. Alright, so this is page 171, okay. So I want you to read through these formulas by yourself, okay. Just read through the formulas, okay. The 1, 2, 3, 4 formulas, okay. Well, here you will have to pay attention to this one, volumes of a cylinder, okay. If we have a cylinder with the radius r and also with height h, the volume of the cylinder can be computed by v equals pi times r squared times by h. Okay, yeah, so we'll use this, so that's why I mentioned this. Okay, so pay attention to this formula. Okay, that's it for page 171. Okay, well, on page 172, I want you to do the entire page of 172. Okay, read through it and then and solve for some blank areas. Okay, page 173. Okay, entire page. Okay, we talk about volume conversions, entire page. Okay, all right. Then let's come to page 174. Non-rectangular volumes, cylinders. Do both question 5 and 6. Okay, yeah, so that's it for section page 174. Okay, all right, on page 175, okay, I would say that let's do everything on page 175, okay? And in this page, we talk about dosage calculations, okay? I will pick up some questions to do, and then the rest you're going to do them by yourself, in group or at home, either way, okay? All right, so that's it, okay? That's it for the first part of section 14, all right? So let's go back to page 172, everyone. We're not going to, this is an example, in the middle of the page 172, this is an example, okay? We're not going to solve for this example, I just want us to look at it, okay? We read through it, okay? Have a brief idea about how to do two-dimensional conversion problem, okay? So, whose turn to read? Lauren, Andrew read, right? So Lauren, can you please read through the entire example for us?
Convert 93.5 inches squared to centimeters squared. Write the initial ratio 93.5 inches squared divided by 1. This is better written as 93.5 inches divided by 1. Notice the 93.5 is not squared, just the units. Multiply by identify ratios 93.5 inches divided by 1. 2.54 centimeters divided by 1 inch. 2.54 centimeters divided by 1 inch. Cancel the units on top that match the units on bottom. 93.5 divided by 1. 2.54 centimeters divided by 1. 2.54 centimeters divided by 1. Multiply the numbers on top and divide by the numbers on the bottom. 93.5 times 2.54 times 2.54 equals 630 centimeters or 600 centimeters squared.
All right. Thanks. Good. Okay. So this example is telling us if we're converting a unit which has a square, okay, so in order to convert from inch square or so-called square inch to square centimeters, okay, so we can write the square inch as inch times by inch. So in order to cancel out both of them, do you think one conversion is enough? No. So that's why we have to do the conversion twice. So we're going to do the conversion twice to get rid of what? This 2 inches, okay, the square of the inch. And then, of course, we'll have 2 centimeters that give us what? square centimeters, okay? And then of course we're going to do the calculations, okay? So this example is telling us for two-dimensional units, okay? Why it's called two-dimensional? Because it has a square, okay? We have to convert how many times? 2 times, okay? For two-dimensional conversion problem, okay? Well, area problem, okay? Because for areas, okay, areas also always have units with what? Square something, right? So that's why, okay, for 2 dimensions questions, do conversion twice to convert, okay? All right, page 173, volume, okay? Volume conversions, okay? So volume conversions are 3-dimensional conversions. Why? Because most of the units, okay, all of the units for most of the units for volume, they're having what? A cube, okay? They're having a cube. So when we do the conversion, see the example, we convert from cubic inch to cubic foot. How many times of the conversions should we do? We have to convert how many times? 3 times to get rid of the cube inches, okay? All right, so these are the idea for the multi-dimensional conversions. Either 2-dimension, convert twice. If a 3-dimensional, we convert how many times? 3 times. Okay. Now let's practice. Okay, let's practice. All right. So let's try question 2 at first. Okay. This question you will see later. You will see it is how many dimension. Okay. I'm gonna ask volunteer read question 2 for us. Leila.
You are putting new carpet in the family room. The room measures 16 feet by 24 feet. The carpet comes in square yards, not square feet. How many square yards of carpet do you need to buy?
All right, good. So we're going to buy the new carpet. The room measures 16 feet by 24 feet. Okay. Well, the carpet comes in square yards. How many square yards of the carpet do you need to buy? What does this question ask us to do? 16 feet by 24 feet, that's a room area, right? That's a room area. If we're going to buy this carpet measures in what? Square yard. Or yard times by yard. So what should we do? We want to convert from what? See, this by that give us the area of the room is a square feet, right? We want to convert into what? Square yard. Right? So this is our aim, from this unit to this unit. How? We need to convert from feet to yard, right? Where do you want to put a foot? Top and bottom, or bottom? Bottom. We put a yard on the top. But do you think one conversion will be enough? No? Right? Alright, so this is 16 feet per 1, 24 feet per 1. So what's the relation between yard and feet? Do you know? Check the table if you don't remember. Yeah, every yard is 3 feet. Right? So this time we can cancel out feet, and we have 2 yards left multiplied by, that gives us a square feet, right? Square yard. So we're going to have square yard, right? And then what will be this number in front of the square yard? 16 times by 24 divided by 3 and then divide by 3. Or you can do it like this. 16 times by 24 divided by 3 times 3 give us what? 9, okay? If you do want to multiply the number from the bottom, you can do is to divide by 1 and then divide by another 1, okay? So what do you get? 누가 knows? 16, 24. So 42.67, right? We'll probably have to rounderize. 42.67. I'm gonna write here. Sorry. Okay. 42.67. Okay. It doesn't say, right, where to round, so I'm just going to keep 2 digits, okay? Square yard. Everybody, what do you feel? It's not that hard, right? You just have to convert twice, right? Convert twice. Alright, now let's move on to page 174. Okay, let's look at the cylinder problem. It's also a volume problem, okay? Alright, so question 6, we'll do this one together. Whose turn to read question 6? Stephanie?
Vintage coffee tin is 7 inches tall and has a radius of 3.5 inches. How many cubic centimeters of coffee grounds will the tin hold?
Okay, good. Okay, vintage coffee tin, you know, what is the shape of it? It's a cylinder, right? It's a cylinder. 7 inches tall, a radius of 3.5 inches. Okay, inch, okay. How many cubic centimeters? Okay, we want cubic centimeters. Okay, of the coffee grounds will the tin hold. So, how many cubic centimeters will it hold? So, it's asked for us to compute what? The volume of this cylinder, right? So, what is the formula to compute a volume? Remember from the previous page? V equals what? Pi times by r squared times by h, right? So pi, okay, if the question does not say use 3.14 for pi, you are going to use a pi value directly from your calculator. I believe every calculator has a pi value, right? Yeah, so use a pi value directly, but not 3.14, okay? Because 3.14 is rounded number, okay? Alright, so we know pi. Do we know the radius? Yes, we do. Radius is what? 3.5 inch, this is radius, square, times by h, 7 inch, right? So let's rewrite this thing, okay? Pi times by 3.5 inch parenthesis square can be written by what? 3.5 square, of course, each r is 3.5, okay, square. What is the unit for the inch parenthesis square? Square inch, right? And then times by 7 inch, right? So together, inch square times by inch give us what? Cubic inch. Okay, I'm going to rewrite this thing as pi times by 3.5 square times by 7 cubic inch. You guys? Because 2 inch comes from the square. 1 inch is from here, so 3 of them together, cubic inch. And 3.5 square times by 7 times by pi. So, we're done. Multiply everything, this is cubic inch. This is what we want from this question? The questions ask us, in what? Resolve in what? Cubic what? Centimeters, right? So that means we have to convert from cubic inch to what? Cubic centimeters. How? Okay, so this is pi times 3.5 square times 7 per line, right? And then this is cubic inches, okay? To convert into cubic centimeters, what do we do? From inch to what? Centimeter. Inch, centimeter. Inch, centimeter. What's the relation between inch and centimeter? Check the table. which equals what? Nobody found? 2.54, right? Right. So this way, cubic inch is gone. We don't like it. Okay, so 1 in 1. Okay, so inch is gone. We have a cubic centimeters left. Okay, and then you're gonna do the calculation. Okay. What do you get? 4,000 something? Oh. Whose turn? Kathleen, tell me.
4,414.54.
14? 54.54?
Well, it's 5.3, but I rounded.
Oh, okay. Everybody, did you use pi directly?
Yeah.
So use pi times by 3.5 times by 3.5 times by 7 times by all of the three numbers. Do everybody get the same answer? Or no? You do? Okay, I read whatever you tell me, okay? So make sure you're typing everything correct, okay? Alright, see, this example is a similar question, and also it's a volume question. See, we convert, right? Alright, so this is page 174. Can we move on or no? Yep. Alright, so page 175, I assigned the entire page, okay? However, in class, we're going to do two of them, okay? 1 and 3. The rest you can mimic and then, do them by yourself, okay? Alright, so question 1, okay? Why mentioning dosage calculations? Because, you might encounter exam questions, okay? So that's why we have to pay attention, right? So question 1, who's turn to read question 1? Irma?
The dosage for a certain drug calls for 15 milligrams per kilograms per day and is divided into 2 doses, 1 dose every 12 hours. If a person weighs 160 pounds, how much of the drug should he or she get in each dose?
Alright, good. Think about that. Some of you guys are a nurse, okay, well, be a nurse, okay. Now this is a real question for us, okay. We're going to give this drug to a patient who weighs 160 pounds. We know that we have to give medicine to patients who depends on the weight, okay. We're not going to give the same amount of dose to two persons. One is 200 pounds, the other one is only 20 pounds, a child, okay, we cannot do that. So it depends on the patient's weight, we give them the specific dosage for their medicine, okay. So this person weighs 160 pounds, okay, we're going to give them the drug for what? Every kilograms for what? 15 milligram. Okay, so every kilogram of the patient's weight, we give them 15 milligram of the drug per day. The entire day's dosage is what? That's this amount. Okay, well, for you, we had the calculation. And then we have to divide our dose into two, okay? This is per day. We have to divide it into 2 because each time you're going to not give the patient like the entire day's dosage, okay? All right, so what kind of conversions can we get? The drug depends on per what? Kilogram. The weight of the patient is in what? Pounds. So at first, we're going to convert from what? Pounds to kilogram. Very good. So 160 pounds, okay? We're going to convert it into kilograms. So what's the relation between kg and pounds? Find from the table.
Equals 0.4536 kilograms.
536, okay? Every pound equals 0.4536 kilograms, okay? So this way, the pounds is gone. All we know is 160 times by 0.4536. That will give us the weight in kilogram for this patient, right? And how about the drug? Every 1 kilogram, we put a kilogram on the bottom because we want to cancel out this kilogram on the top, okay? We will give what? 50 milligram of the drug to the patient, right? So this way, we know how much drug. But this is a dose for what? For a whole day. So each dose is going to be what? Okay, yeah, this is per 50 mg per 1 kg per what? Per 1 day, right? Per 1 day. So I have to put both, okay? 50 mg per kg per 1 day. Okay. And then we know that every day there are 2 doses, right? 2 doses. So now you see they cancel out. Okay. Now we have a mg per dose. Okay, so eventually we'll have the medicine in milligram per what? Per dose. Okay, so multiply everything from the top and divide by what? 2. Okay, divide by 2. What do you think about this question? Well, it looks very fancy, but once we work on it, it's okay, right? What is your answer? What do you get for here? 544 milligram per dose. Everybody? Well, yeah, type in everything correctly, and then we should get a 544 milligram per dose. What? 0.32. Oh, okay. 0.32. Yeah, I would say round it to the whole number, okay? Milligram, okay. So 544. But if you put a 0.37, that's fine, okay? Yeah, 0.37, that's okay. You can see the question 2 is exactly the same thing for 1, so you can mimic and do it. Okay, maybe you can do it. Questions 3 and 4, they're very similar, so let's do 3. Okay, who's turn to read question 3?
If the drug has a concentration of 375 milligrams per milliliter, how many milliliters are needed to get 1 gram of drug?
Alright, good. Concentration of 375 milligram per 10 milliliter. How many milliliter are needed to give 1 gram of the drug? Okay, so the given one is what? 1 gram. So 1 gram. Okay, we want to convert from what? Gram. Sorry, 1 gram. Okay, we want to convert from gram to what? ml, right? To ml. So from 1 gram to ml, so far what we know is what? The conversion from from G to ml. Okay, we want to convert from G to ml, right? Now we know mg to ml. So we want G to ml because it's 1 gram, right? So far, what we know is from what? Mg to what? ml. So in order to convert, what should we do? We should know how to convert from G to what? ML, then from ML to what? Sorry, from G to MG, then from MG to what? ML. Do you see that? How many ML? So this is a required one, desired one. If 1 gram is given, right? So gram is unwanted. So what we want to do is this one. We want to do this conversion. The given information is from mg to ml. But we need from G to ml. So what do? We have to convert from G, okay, I was like this, 1G, okay? We are going to convert from G to what? mg first. Okay, from G to mg. Then from mg to what? ml. So this way we'll get ml left. You guys see that? Okay, you see that? Okay, the thing is, from gram to m-gram, mg, so far we learned is what? Convert from decimal points, right? So every 1 gram equals how many of the milligram? If we do not want to convert decimal points from the prefixes, we know that gram is here, mg is here, so there's 3 units away. So every 1 mg equals 1,000th of g. So reversely, every 1 gram should equal what? 1,000 times of what? mg, right? Yeah. So every 1g equals 1,000 of mg. Okay. So every 1g equals 1,000 of mg, right? So this way, G is gone. Okay. And then the relation between mg and ml is 375 mg per 10 ml. Right? Now the mg cancelled, we will only have ml. One times 1,000 times 10 divided by 375. I got 26.7 milliliter. Is my answer the same as yours? You do? Okay. Alright, so this is question 3 and 4, okay? Question 5 and 6 are more similar or not similar, okay? So I want you to try by yourself, okay? Yeah, try by yourself. So now we're done for the first part of section 14, okay? Well, because of the class time is very limited, I don't know, okay? So I would say that you're going to try to do all of the rest of the questions that I assigned, which that you cannot finish in class. Take them home, finish them up, check with the answer key. Do you know where to check answer key? Under modules, there is a book solution. Check the answer key from section 14. Get this half section 14 done, okay? Because next time when we come back to class, we may not come back here. Unless you have questions, okay? So I would say that for all of the conversions, section 13 conversions, section 14, this is an extension about conversions. We're done for conversions, okay? All right.